So now we're going to look at probability with fractional dartboards. Kind of the idea would be if I threw a dart at this board, just sort of randomly, not aiming it, and I say what's the chance of it landing in certain spaces or certain amounts. And so if you look at the spaces, obviously B has more space, so we would assume that the probability of B would be greater than either A or C. But again, we look at them as fractions of the whole amount. So if you look at the section A, it's if we think of the whole thing broken up into pieces like that, A would be 1/4 of the dartboard. So you'd have a 1 in 4 or 1/4 probability of hitting A if you were just to sort of throw randomly. And then here's that little symbol again that means not. So this means not A. So if the probability of hitting A is 1/4, the probability of hitting everything else or not A is half and another quarter, which is 3/4. It's the rest of the dartboard. And sometimes we want to use OR statements, so we combine places. Remember, OR gives you more. So the B and the C together, B or C. If I hit here or here, that's all of this. So it's really the same as not A. It's 3/4 of the dartboard is B or C, 3/4 of that space. So we can look at another example of this with the dartboard kind of cut slightly differently. And sometimes it helps just to think about each section, like section A is half of the dartboard, section B is 1/4. And so if that's 1/4, then each of these, if you think of the whole thing cut up into pieces like this, if I could kind of cut it all up like that, you can see that there would be 1, 2, 3, 4, 5, 6, 7, 8 pieces. So each of those is 1/8 of the entire dartboard. So now we can use those fractions together to find the different probabilities. So if we just look at the probability of B, that section only, that's 1/4. The probability of C or D are these together, and so that's really no different than B, or no different than 1/4 of this whole dartboard. So that those two together make 1/4. Probability of D all by itself is just the 1/8. And then so the probability of not D, which means everything else on here, would be all the rest of the eighths, which would be 7 of them, 7/8. If this is 1/8, this has to be the rest, the 7/8 that make up the rest of the dartboard. So if we look at this last example, again, if we just take each piece and try to figure out what fraction of them, these are a little bit more challenging to figure out. But A, again, if you think of A as 1/4 of the whole dartboard, 1/4 of a section, and then so if this is 1/4, or if we think of cutting it all up into pieces of that size, again, these pieces, if we cut the whole dartboard up into those size pieces, there would be 8 of them. So this is 1/8, and this is 1/8, and this is 1/8. And so that means that this last section would be 1, 2, 3/8 of the dartboard, because it would cut up into 3 pieces of that size. So if we go to the probabilities, probability of this part, A, is 1/4. Probability of D is 1/8. Probability of E is 3/8. And the probability of D or C, these two together, if you take 2/8, 1/8 and 1/8 is 2/8, or it's really, simplify the fraction, we should say 1/4, because you put 2 of those together and you get 1/4 of the dartboard. And that's how you do sort of area. This is an area model of probability when we look at the areas of different shapes and the fraction of the whole shape.